You've heard the terms flying around everywhere, right? AI, machine learning, deep learning. People use them like they're all the same thing, but they're not. Not even close. So what is the real difference? And why does it actually matter? Okay, let's get into it and clear this up once and for all. So let's ask the big question right up front. Are AI, machine learning, and deep learning just fancy marketing terms for the exact same tech? The answer is a hard no. You've actually got distinct, nested layers here, and figuring out how they fit together is honestly the key to understanding the technology that's shaping our entire world. Here's how we're going to break this down. Think of it like a set of those Russian nesting dolls. We'll start with the biggest doll on the outside. That's artificial intelligence. Then we're going to open it up and find machine learning tucked inside. And then we'll go one level deeper and find deep learning. Once we see how it all fits, we'll get to the fun part, seeing where this tech shows up in your everyday life. First things first, let's talk about the big one, artificial intelligence. You really got to think of this as the giant umbrella that covers everything else we're going to talk about today. It's the broadest concept, the original idea, and the foundation for all of it. So what is it really? Well, at its most basic level, AI is any technique that lets a computer mimic human intelligence. This can be anything, from solving problems to making decisions to even understanding language. The whole goal is just simulation, making a machine act or think like a human. And this is the perfect way to picture how these concepts relate. It really is just like those Russian dolls. AI is the biggest, outermost doll. It's the whole field of study that started decades ago. And inside of it, that's where we're going to find the others. Seriously, keep this image in your head. It's the key to making it all click. The first versions of AI weren't smart in the way we think of it now. A lot of it was just based on a really complicated set of if this, then that rules. Think about those old school customer service chatbots that just had a list of pre-canned answers, or a robot on a car assembly line that does the same exact weld a million times. They're simulating intelligence, for sure, but they can't learn or adapt on their own. So if that early AI was just following a list of rules, how did it get, smarter? The answer is by learning. And that means it's time to open up that first Russian doll and say hello to machine learning. This is where things start to get really interesting. And here is the absolute game changer. Instead of a programmer writing thousands of lines of rules, a machine learning system gets fed a massive amount of data, and it figures out the rules for itself. It finds the patterns, it makes the connections, and it learns what to do instead of just being told. So again, just go back to that Russian doll in your mind. Machine learning isn't some totally separate thing from AI. It's a very powerful way of achieving AI. It's that next layer down, nested right inside. I guarantee you are using machine learning all day, every day. That spam filter in your email that just knows what's junk, that's ML. It learned from seeing millions of spammy emails. Or what about when your credit card company sends you a text about a suspicious charge? That's ML too. It learned your personal spending patterns. It's the silent engine behind so much of what we do online. All right, it's time to open the next doll. Tucked inside the world of machine learning, there's an even more specialized and frankly more powerful technique, deep learning. Now this is the real cutting-edge stuff, and it gets its big ideas from the most complex machine we know of, the human brain itself. So deep learning uses this special structure that's inspired by our brains, and it's called a neural network. Just picture these layers of interconnected digital neurons that pass information to each other. When you have a lot of layers, and that's the deep part of deep learning, the network can teach itself to find incredibly subtle and complex patterns in raw, messy data. So where do we see this incredible power in action? Well, in some of the most mind-blowing tech out there. A self-driving car figuring out if that's a pedestrian or a lamppost. An AI helping a doctor spot a tiny tumor in an MRI scan. Your phone actually understanding what you're saying when you talk to Siri. These are all jobs that need a deep understanding of messy, real-world data, like images and sound. And that is where deep learning is an absolute superstar. Okay, so quick recap. We've met the whole family. AI, the grandparent, machine learning, the parent, and deep learning, the kid. Now that we get the relationships, let's put machine learning and deep learning right next to each other to really hammer home what makes them different. Now this, right here, is probably the single biggest difference between the two. With traditional machine learning, a person, a data scientist, has to do a ton of work up front. They have to prep the data and basically tell the system, hey, look for these specific features. With deep learning, you can just dump in the raw data. You can give it a million pictures of cats, and the neural network figures out what makes a cat a cat. The pointy ears, the whiskers, all by itself. Machine learning is fantastic when you've got nice, clean, organized data, like rows and columns in a spreadsheet. But deep learning, with all its complexity, it thrives in the mess. It's built from the ground up to handle the massive amounts of unstructured stuff that make up our actual world: images, audio files, plain text from the internet. But there is a trade-off here. Because deep learning models are so incredibly complex, they need a staggering amount of data and a ton of computing power to get trained up. And that can take a long time. Machine learning is often way faster if you have a smaller, simpler data set. But, and this is a big but, when you have a truly massive data set, the level of accuracy you can get from a deep learning model is often unbelievable, blowing pretty much everything else out of the water. Okay. Let's bring all of this home. We've talked about the theory, but let's see how this whole family of tech actually pops up in your day-to-day life, because you're using it way more than you probably think. First, let's look at that big umbrella, AI. Every time your phone unlocks just by looking at your face, that's AI. Using an app on your phone to translate a menu in a foreign country in real time, yep, that's AI. Even those customer service chatbots that are actually helpful and seem to understand what you're asking, that's a more modern form of AI at work. Now let's zoom in to machine learning. We already talked about spam filters and fraud detection. But think about this. Every single time Netflix or Amazon suggests a new show to watch or any product to buy, that is a machine learning algorithm that has learned your tastes based on everything you've done before. And finally, we've got the really heavy-duty stuff that's powered by deep learning. The absolute magic that lets Alexa or Siri understand the weird ways we all talk. The incredible visual processing that lets a car see and navigate a busy street. And maybe most importantly, the life-saving ability to help a doctor find signs of disease way earlier and more accurately than ever before. So look, if you only remember one thing from all this, let it be this right here. This isn't a competition between three different things. It's a hierarchy. Deep learning is a type of machine learning, and machine learning is a way to achieve artificial intelligence. One fits right inside the other, just like those Russian dolls. We've spent our time today talking about the powerful AI we have right now. But this field is always moving, always pushing towards what's next. We're talking about things like a theory of mind, where an AI could actually understand human emotions, or maybe even become self-aware. And that opens up a whole new universe of fascinating and very complex questions for our future. What happens then? It's definitely something to think about.